Okay, so in the previous video we talked about number 4, but let's make sure we get that answered on your notes. It says, is it possible to show that triangle BUD is congruent to triangle B prime U prime R prime? So remember we said the height of Bud would not have changed when he moved. The relationship he had with the ground would be a right angle in both of those triangles. And remember, his eyesight is what was also staying the same. He was looking at the top of the cactus branch to the edge of the ravine, and then he walked to where his eyesight from the top of the cactus branch hit Travis's feet. So that length B prime R prime is congruent to BD. So yes, we can prove that the triangles are congruent by HL. The hypotenuses are his eyesight, and the leg is his height. And remember, it is a right triangle because his height is perpendicular to the ground. All right, so let's look back at what we started with in the overview. We met a land surveyor who was trying to find the distance across the lake. But remember, they measured the distance indirectly. They were measuring the distance on the ground, which was congruent to the distance across the lake. So we're going to help the surveyor prove the method that was used. And in order to write a proof, you need to start off with given information and decide what we're trying to prove. So I want you to pause the video for just a moment, and I want you to think about what those would be for this problem. What information was given, and what information were we trying to prove in order to find the distance across the pond. So when you have thought about that for a moment, you can restart the video. Okay, so since the park ranger had already measured some congruent distances, we're going to use those as our given statements. So remember, DB and BC were both 40 feet, and AB and BE were both 30 feet. So we already have those known to be congruent distances. So your given information should be segment AB is congruent to segment BE, and segment BC is congruent to segment BD. What we're trying to prove is that we can use these congruent triangles to measure AC and know that it is for sure the same thing as the distance across the pond, which was DE. So that's what we're trying to prove, that segment AC is congruent to segment DE. Now in question 5 in your notes, this is just a review. It's the same thing as the back of your 9.3 notes, where you just have the pictures for each of our 5 shortcuts, and you should be able to recognize those now. So all 3 sides congruent to all 3 sides is the SSS postulate. 2 sides in the included angle congruent to 2 sides in the included angle is SAS. The next 2 have 2 angles in one side, but this one is the included side, so that is ASA. This one is the non-included side, so that is SAA or AAS, same thing. And this is the one that only works for right triangles, and it's the Hypotenuse Leg Theorem, HL. All right, so in our drawing here, if we were thinking about working our proof, we have the given information marked with the tick marks already. What other information would we know to be true? Hopefully you recognize that we have a pair of vertical angles that we could also mark at vertex B. So we would know angle ABC is congruent to angle EBD because they are vertical angles. Go ahead and mark those on your figure in your notes as well. So here we're marking these vertical angles as being congruent. So do you see what triangles are congruent now and how we know that they are? So remember, when you write your congruent statement, the order you write the letters is super important. So I'm going to name the first triangle alphabetically. I'm going to name it triangle ABC. Then my congruent symbol. Don't forget your triangle symbol on your second name. Some of you are forgetting that. When I name the second triangle, I have to show the corresponding parts. So angle A from the first triangle, its sides, one of them has 1 tick mark and one of them has none. So I'm looking over here for the angle that has 1 tick mark on one side and no tick marks on the other, and that is E. Angle B was the vertical angle, so it's congruent to angle B of the other triangle, so B would be the middle letter. and the only other letter of this triangle is D. So we would write triangle ABC is congruent to triangle EBD. What shortcut did we use? Well, we had two sides and one angle. The angle was the included angle of the two sides. So that shortcut is SAS. So now that we have our plan of attack, we should be able to easily transfer that into a proof. So on number 6 in your notes, we've already stated the given and the proof, so you'll need to write that on number 6. You're writing the given, which is segment AB congruent to segment BE, and segment CB is congruent to segment BD. What we're trying to prove, remember, is that the direct measurement we can make of segment AC is congruent to the indirect measure we're trying to make for the distance across the pond, which is segment DE. So on number 7, we already did that. We marked our vertical angles. We already answered this up here, sorry, in our notes. That's number 7. So on number 8, I want you to try to go ahead and write out that proof. You can do it as a 2-column proof like I've shown that I'm doing here, and then you can restart the video to see how you did writing that on your own. Okay, so remember, typically your given information would be your first step, and so I wrote the 2 pairs of corresponding sides we knew and put that as being given. That's the reason. So remember what we added as markings after that? That was these vertical angles. So that would need to be your second step, that angle ABC is congruent to angle DBE, and how do we know that to be true? Well, there's 2 ways you can write that reason. You can either write vertical angles are congruent, that's the theorem written out in words, or you can put the vertical angles theorem. What you cannot put is just vertical angles, nor could you put definition of vertical angles. Both of those would be counted wrong. So you can either have vertical angles are congruent, which is what the theorem says, or the name of the theorem, which is vertical angles theorem. Either one of those would work. So remember, you're already going to mark those in your notes. We've already done that. So now that we have those marked, we can say the 2 triangles are congruent to each other. So your third step would be triangle ABC is congruent to triangle EBD. Remember, the order you write those letters is super important to show those corresponding parts. Your reason is always going to be one of those 5 shortcuts. Anytime you have congruent triangles, it better be one of the 5 shortcuts that you use as your reason. And ours was SAS in this case. So remember, we're using congruent triangles as a tool in this topic. So we're not stopping our proof here. We're taking it a step farther. What are we trying to prove? That AC and DE are congruent as a result of knowing the triangles are congruent. So our last step is segment AC is congruent to segment DE. Now, what did we learn today that will be our reason? How do we know if triangles are congruent that all 6 parts of those congruent triangles are congruent? That's where Cpctc comes in. So since we know the triangles are congruent, all 6 pairs of corresponding parts are also congruent. So our reason would simply be Cpctc. Corresponding parts of congruent triangles are congruent. This is a very important part of your notes here, so make sure that you get the answers here and also study these. This is super, super important. So these are important things about using Cpctc in a proof. So the first one is you always have to prove your triangles are congruent before you can use Cpctc in a proof. So again, the triangle congruent statement will be first. Cpctc follows that in a proof. Never ever would you have Cpctc before you're saying the triangles are congruent. Triangles have to be congruent first, then you can use Cpctc. Also, in a proof, you would never use Cpctc as a reason for why 2 triangles are congruent. If you were saying 2 triangles are congruent, you have to use one of our 5 shortcuts, like you have in number 5 of your notes. Those are the only choices you can have for reasons for triangles being congruent. The last important thing is if you are using Cpctc as a reason in a proof, then your statement will always either be two segments, which are two sides, being congruent, or two angles being congruent. That's what the corresponding parts of congruent triangles are. Their corresponding sides and their corresponding angles. So like the last step of our proof was corresponding segments, sides, right? So anytime you use Cpctc, it's to say two segments are congruent or two angles are congruent. So how many pairs of congruent corresponding parts do congruent triangles have? Remember, they have 6. 3 pairs of angles, 3 pairs of sides. There's a couple of things I want to point out in your assignment today. When you are completing your proof here, don't forget to always mark on your figure the information that you're given, and then as you go through your proof, you're going to be marking it as well. That's what's going to allow you to know what shortcut is being used to prove the triangles are congruent. Also be careful on your choices here, the difference between these that have angle symbols and this one which is triangles. So this is a triangle congruence, these are angle congruencies, this is a side congruency, so just be really careful with your symbols there. And then one more thing on the back here on number 9, make sure that you do all of the things that ask you to do. So you're going to mark the congruencies on the given information here. You're going to tell which triangles are congruent, so triangle what is congruent to triangle what, and then why. Which congruent shortcut did you use? SSS, SAS, ASA, SAA, or HL? And then how can you use the fact that the triangles are congruent to prove that angle N is congruent to angle P? If you do this correctly, this should be easy because this is just using this information in proof form then. All right, good luck.